This is looking ahead 3, subtracting polynomials. Recall that when subtracting integers, we simply add the opposite. For example, when we wanted to subtract 5 minus negative 2, we changed the subtraction to addition, and we changed the negative 2 to a positive 2. Similarly, to subtract polynomials, change the signs of the terms of the polynomial that is being subtracted, and then add like terms. So for example 1, when we subtract 4x plus 5 minus 2x plus 3, we keep the 4x plus 5 the same, and then we change the subtraction to addition, and we change the signs of both of these. So the 2x will become a negative 2x, and the 3 will become a negative 3. And now this looks just like what we did in looking ahead section 2. So now we combine like terms. We have 4x and negative 2x is just positive 2x, and then 5 and negative 3 is plus 2. Let's do the same thing for this example. So we'll keep the first polynomial the same, and then we change subtraction to addition, and we change the sign of both. So negative x becomes positive x, minus 1 becomes plus 1. And now we combine like terms. So there's nothing that goes with this 2x squared, so we'll just keep it as 2x squared. We have negative 3x plus x. Negative 3 plus 1 is negative 2, so that's minus 2x. And negative 5 plus 1 is negative 4. Okay, so for the two try-it-yourself problems, you're going to do the same thing. Change the subtraction to addition, change the sign of each of the terms in the polynomial that's being subtracted, and then combine like terms. So pause the video, work through those two, and then press play to continue. Okay, for the first one, you should get 5x minus 4. And for the second one, you should get x squared plus 4x. Okay. Just as with adding polynomials, you can also arrange like terms in columns when subtracting. Just remember to change the signs of the terms of the polynomial being subtracted. So this is just a different way to set up these subtraction problems. So if I start with the original polynomial, 5x squared plus 4x plus 2. Now when I subtract each of these, I'm going to change the sign of each one. So I'm going to change the x squared to a negative x squared, and I put that under this one because they're like terms. And I'm going to change the minus 3x to a plus 3x, and that would go with this one, so that would be plus 3x underneath the 4x. And there's no like term to add to this one. So now because I've changed the signs as I've written them down, now I can just add straight down my columns. So 5x squared and minus x squared is 4x squared, 5 minus 1, and then 4 plus 3, that would give me 7x, and then bring down the plus 2. Okay, so for the try it yourself problem, my intention was for you to try at least setting this up in columns. You don't have to do it that way, but that's just, again, just a different way to set up the subtraction. So either way, whether by columns or just by changing to addition and combining like terms, go ahead and answer that question. And when you're ready to check your answer, press play. Okay, for this one, you should have gotten 4x squared plus 7x minus 6. Okay, so let's go ahead and move on to looking ahead section 4, which is multiplying a binomial by a monomial. So we've got a new term here, a binomial. A binomial is a polynomial with two terms. That prefix there, bi, means two, so it's a polynomial with two terms. To multiply a binomial by a monomial, we use the distributive property, just like we learned several chapters ago. So remember, when you have something like this in parentheses with either addition or subtraction, and something multiplied by that whole quantity, we just distribute. So a times b plus a times c. That's what we have. So that's what we'll use to multiply a binomial by a monomial. So for the first example, we want to multiply x times x plus 6. So in order to do that, we multiply x times x, which is x squared. Now be careful here, it's not 2x because we're not adding, it's x squared because we're multiplying. So x times x is x squared, and then x times 6 is 6x. Okay, let's do the same thing for b. We multiply x times 4x squared. That'll give us 4x to the third. And then x times 1 is x. Okay, and one more. Here when we multiply 2x to the third times 3x squared, remember with these we multiply the coefficients, so 2 times 3 is 6. And then with the exponents, because the exponents show how many times that variable is multiplied, this is 3x's times 2 more x's. So we're adding the exponents here. I know it's been a while since we've seen exponent rules, so just refresh your memory on that rule. So this should be x to the fifth. All right, and then we multiply 2x to the third times minus 2x. That'll give us minus 2 times 2, which is 4. And then x to the third times x is x to the fourth. Okay, so there's 3 try it yourself problems just below that. So pause the video and work through each of those. When you're ready to check your answers, press play. Okay, for A, you should have gotten 14x plus 35. For B, 12x to the third minus 28x. And for C, 3y to the fifth plus 2y to the fourth. All right, we can simplify expressions by distributing to clear parentheses and then combining like terms. So if I wanted to simplify this expression, what I would do, since there are parentheses involved, I would need to first distribute to clear any parentheses, and then I can combine like terms just like we did in looking ahead section 1. So let's get rid of these parentheses by distributing here. So 4x times x is 4x squared, and then 4x times 3 is 12x. And then here, this might look like you have to distribute, but there's just one term here. So all we're really doing is multiplying. So this is minus 3, and then x times x is x squared. Okay, and then from here, just like we did in looking ahead section 1, we just want to combine like terms. So we have a 4x squared that goes with a minus 3x squared. 4 minus 3 is 1, so that's 1x squared, or just x squared, and then plus 12x. And notice here, again, I'm still writing my polynomial answers in descending powers. This is a power of 2, this is a power of 1. So 2, 1. With any polynomials, you always write them in descending powers. Okay, so there are two examples, or 2 try-it-yourself problems, right below this for you to do. So pause the video, work through those 2, and when you're ready to check your answers, press play. Okay, for 2a, you should have gotten 2a squared minus 6a. And then for 2b, you should have gotten negative 13n squared plus 28. And if you didn't get this, one thing I would look for, because this is a very common mistake, is that when you distributed this, you distributed it as a negative 4. So when you multiply here, you should get a positive because you have a minus and a minus. So those 2 negatives would give you a plus 28. So if you didn't get that, that would be a good place to look. Actually, I'm just realizing that I have a mistake on this one. Back up a step. Yeah, maybe if you got the wrong answer, you should check with me first to see if maybe I had the wrong answer. I left off my n cubed, so you should actually have 3n cubed minus 16n squared plus 28. Apparently I couldn't read my own handwriting, and I thought that that 3n cubed was a 3n squared. So this is correct. That's much better. And again, if you didn't get plus 28 here, that's a common mistake of not distributing the negative to the second number also. Okay. Hey, for once I actually caught a mistake before the video was done. All right, let's continue. So we can use the same properties of equality that we learned in chapter 4 to solve equations with polynomials. And at this level, all of our equations with polynomials, if they have a variable squared, the squareds will cancel on both sides of the equation because we don't actually yet know how to solve an equation that has like an x squared in it or something like that. But basically, we're just going to solve this like a normal equation, just like we usually would. So here, when I see an equation with parentheses, I first need to distribute, just like we did back in chapter 4 and chapter 5. So on this side, I would distribute the w to both of these. W times w is w squared, and then w times 12 is 12w. And I do the same thing on this side. W times w is w squared, w times 14 is 14w, and just bring down the plus 12. Okay, so from here, if we could combine like terms on either side of the equation, we would. Now, not across the equal sign. I can't add w squared and w squared, for example, because there's an equal sign between there. Remember, when we solved equations, I mentioned that you could draw a line through the equal sign, and anything that's on the same side you could combine if they're like terms, but if they're not on the same side, you can't. So if we could combine like terms, we would, but here these are not like terms, and there are no like terms over here either. So our next step, of course, is to add and subtract to get the things that should be like terms on the same side of the equation. So here I see I have w squared and w squared. And like I said, the w squareds, or whatever the variable is squared, should cancel out of all of these equations that we'll do at this point. So if I subtract w squared from both sides, w squared minus w squared is 0, and w squared minus w squared is also 0. So what we end up with is just 12w on this side, and then 14w plus 12 on this side. So now I want all the terms with a w in them on one side of the equation and the number without a w on the other side. So since this is the only number without a w, let's leave this over here by itself by subtracting 14w. And 12 minus 14 is negative 2. So this is negative 2w equals, bring down the 12. And now the last step is divide by negative 2. So we get w equals negative 6. Okay, so there's a try it yourself problem just below this one, two of them actually, for you to try on your own. So go ahead and pause the video, work through those two problems. Um, I would find it very hard to believe that you could do these without showing at least some work. So you should have some sort of work shown for these, just like when we did chapter 4 and chapter 5, where you had to show your work just like this, where you have the whole thing written out and you subtracted from both sides, you're canceling stuff out. Your work for Try It Yourself 3A and 3B should look pretty much identical to this. This is one of those things that's just non-negotiable as far as work goes. So work through those two problems, make sure to show your work, and then when you're ready to check your answers, press play. Okay, for the first one, you should get n equals negative 3. And for the second one, c equals 17. And for this one, what you probably noticed if you did this correctly was that there actually were like terms on this side of the equation that you could combine. So there There weren't any in this problem and also in the example that we did, but in this one there should have been some like terms that you could combine on the left side of the equation before you started adding and subtracting. But if, of course, for some reason you didn't get either of those solutions, go back and check your work, and if you can't find where your mistake is, send me an email so that we can see if we can figure that out together. All right, that is it for these two sections.